Hello, 30-3s. Let us do a little bit of work with the cosine law. We have done the sine law, and now we're moving on to the cosine law. Well, before we start into actual calculations, let's take a look at why we have the cosine law. The sine law, hopefully you understand at this point, is for situations where you have to find a side length or an angle size. But if I wanted to find this angle here, and I knew the side opposite was 18, well, what's important for the sine law to work? Oh, I hope you can answer this for me, because what you need to know is you need to make sure that you have an angle side pairing. So you would have to know that this angle was, let's say it's about 40 degrees, and that this side was 12. If I needed to know that angle, if I want to use the sine law, I have to have an angle and the side opposite. Talked a lot about that need for an angle side pairing for the sine law. Well, the cosine law. The cosine law will give us situations where we want to find that angle as well, but we're given three sides. Well, if I have three sides, I don't have an angle side pairing. I have an angle and the side opposite, but that's what I'm trying to calculate. I don't have an angle side pairing given. So that's where the sine law will fall apart. Another situation might be where I have an angle. Let's say the angle here, for argument's sake, is 10 degrees. If we had 10 degrees, and then I had two other sides, that's 25, this is 30. Well, if I want to calculate this side here, I have angle 10, and I want that side, but I don't have an angle side pairing. I don't have an actual angle and a side paired up. So that's what you need for the sine law. And if you don't have those things, then we go to the cosine law. So there's a perfect example of the cosine law. We have, in this case, an angle, and we have two sides given to us, C and B, but I don't have an angle side pairing. B would need to give me angle B for an angle side pairing. I don't have it. I would need angle C to have the angle side pairing for side C and angle C, but I don't have it. We want angle A. We don't have the angle opposite. We don't have an angle side pairing. So what's interesting with the cosine law is it's all about A, recognizing what you have, but B, making sure you understand the formula that you have. This is the formula we would use to calculate a side length. It's going to be a different formula for angle size, but that's the formula if we want to calculate a side length. Please note, we're going to try to find angle or side A. I'm going to punch all this information in. But what we have to be careful of is that when I get an answer or a value here, we're not going to have A yet. We have A squared will equal whatever all that is. We always have to finish by square rooting. Don't forget, you have to finish by square rooting so that you get an A by itself. That's important to remember, and we'll talk about it as we go. Now, the other thing that you have to be careful of with this, what if I had, because this question is asking, what's the size of angle A? Well, I would be able to punch in side B, punch in side C, side B and C again in the formula, and cosine of the angle that we know. So all the information's there to find angle A, or sorry, side A. But what if I have the exact same idea where we now have angle C, we have me just finish labeling here. We have side A, we have side A, and we have side B. And we want to know what side C is. Well, we have to be careful because our formula here solves for A squared. But in this question, we're trying to calculate, this is side C. So this formula technically won't work because we're solving for A. Well, understand there's two things you can do. Well, instead of finding side A, we could rewrite the formula to say we want to calculate side C, which is what we do. But we have to then make some changes. Here, if we calculated side A, we were using angle A. So our formula would also have to change. So we're calculating cosine of C because A corresponds to A and C corresponds to C. But the other thing that changes is now I have a C here. I don't want C here. Our C would really be replaced with A. So we have to understand that we have to have the right information in our formula. If we're trying to find angle A, yes, this formula is perfect, as it initially was. But if we're trying to find side C, we need to change the variables so that we now have the right formula for finding C. Well, with that initial formula, what if we wanted to find side B? Well, what else would have to change? Well, A squared, when we were solving A, we used cosine A. So if we're finding B, we would have to use cosine B. Well, then our B won't work anymore. So now we would go A squared. C would still be okay in this case because we're changing it to B. So we would need to change and the B here because our B is what we're finding. So we would need that then to be an A. So we have to manipulate formula for each situation. We'll talk about it as we go. Something to think about. It's simply a matter, like I said, of identifying and solving. So here's the situation. We are trying to find side A, opposite angle A, which is good. Let's finish labeling. Side 8 is opposite angle C, so that is side C. And 4 is opposite angle B, so that'll be side B. There you go. To find A, we need to know side B, which we do, side C, which we do. There's B and C again, and the cosine of angle A, which we know. So everything's there. We simply substitute in and solve. 4 squared plus 8 squared minus 2 times B, which is 4, times C, which is 8, times cosine of angle A, and angle A is 88 degrees. Big formula, lots to plug into a calculator. You have to be careful. I like to break it down into a couple steps to eliminate errors. I can do 4 squared. I can do 8 squared. And then I want to calculate that big chunk of multiplying at once. By breaking it into these little steps, it will help hopefully eliminate errors that you might see. So if I punch all of that into my calculator and break it into those little steps, I'll have 16 plus 64, and then let's go to our calculator. We would have 2 times 4 times 8 times cosine of 88, and we get 2.23356, so 2.23. I can add 2.23 into this, and A squared will equal 77.77. There's my value. But like I said earlier, that's not a yet, because this is what a squared equals. How do I get a by itself? I square root. So we need to square root the 77.77, and we get to one decimal place 8.8 for a length of a. And there you go. It's simply a matter of plugging into the formula, but understanding the values you have. Let's try another one. Page 18, let's take a look at example 2. Now, example 2 at the bottom there actually doesn't give us a diagram. Now, diagrams don't have to be perfect. It's not a right triangle, so I'm just going to put a non-right triangle. We see that we have side JK, KL, and an angle L. So I'm just going to label my triangle. So I have my vertices JKL, and it says JK is 12. So JK is 12, but that's also opposite angle L. So we can call that side L. And KL is 18. So KL is 18. It's opposite angle J, so that's also side J. And the last thing we have is angle L is 76 degrees. All right. Well, our formula is all about a squared, b squared, c squared, 2bc cosine A. So this is what makes it a little bit confusing. The question is, what side are we trying to find in this question? It tells us we want to find the length of JK. Look at that. I messed up. I apologize. We want JK. I wrote this question down wrong in my book. Side KL is 18 and JK is 12. Wait a sec, that's what I have. JL is 12. Sorry. I apologize for that. I wrote it down wrong. So JL is 12. So I need to change this a bit. Let me just make some adjustments. JL is 12. And that isn't side L anymore. JL is opposite side K. So that would be side K. Now, we want to determine the length of JK. Here's what we want to know. Sorry about that misunderstanding. Look in your book. Don't look at what's up here right now, and it'll make sense. Now, here's where JKL with a squared, b squared, c squared, bc cosine A. We don't have ABC. We have choices. One choice that you could do is to rewrite the formula. We're trying to find side L. So we know that we're trying to find L squared. Well, if I'm going to find side A, I have to use cosine A, so I'm going to have to use cosine of L. But my other sides, B and C, don't change. What are the two sides besides B and C? J and K. So I could simply change B and C to J's and K's. That's one possibility. Finding side L, so we use cosine L. B and C are the other two sides, and I could plug into that formula. That's one possibility. The other possibility that I have had students over the years do, if I just quickly resketch this, well, what are we trying to find? We're trying to find this side. So we could call that side side A. That would mean this is angle A. What else do we know? Well, we know that our formula uses B and C, so I'm going to go B and I'm going to go C. Now I can put lengths in here, just copy. This was length of 12. This was a length of 18. This was 76 to find A. So I can just relabel it if that helps. Because angle C is across from side C and angle B is across from side B. And now I could use the original formula because we're trying to find A using side B and C and angle A. So you can change the formula or you can change the triangle, whichever works for you. I like to use the original, so that's what I'm going to do. So here we go. We're trying to find A squared, which is B squared, which is now 18, plus C squared, which is 12. So we have 18 squared plus 12 squared minus 2 times B, which is 18, times C, which is 12, times cosine of angle A, which is 76 degrees. So I simply took my JKL triangle, realized I'm solving for A, so I have angle A, and I then have sides B and C across from angles B and C and work accordingly. At this point, A squared equals, do some punching into your calculator. 18 squared gives us 324. 12 squared gives us 144. And I then want to subtract 2 times 18 times 12 times cosine 76. And this whole thing is 104.510. So if I do all of that calculation, we end up with A squared equal to 363.49. And at that point, I don't want A squared, I want A, so I square root, and A works out to be 19.1. So the cosine formula for sides. Last one. Turn to page 20. Page 20 now gives us a bit of a diagram for that question. This is example 5. Basically, really quick, just to show you what it's all about. If they have a hill and they want to make a tunnel through it, because they can't just take a tape measure and go straight across a hill, it doesn't work. What they're able to do is they will move away from the hill a bit, because the hill would be sticking out, is that if they move away from the hill, they could measure to where the tunnel's going to start and to where the tunnel's going to start. Because the mountain kind of might come out or the hill might come out a bit, they can work around that. And now they create a triangle that they can use the cosine law with, because the length from here to here is what they want to calculate, which they can't because that's through a round hill, but they can get some other measures that are helpful. And it tells us a tunnel is to be built through a hill to connect points A and B in a straight line. Point C is chosen away from A and B, away from the hill. They can get angle C to be 67.5 degrees. They can get CA here to be 3.65 kilometers. And they can get CB to be 5.18 kilometers. So what do we have? We need to calculate the distance the tunnel would be. So I'm going to re-sketch that over here, kind of get an idea of it, but I'm not going to label it yet. I'm going to put numbers on, but that's it. We know we have 67.5 here. We know we have 5.18 kilometers here, and we have 3.65 kilometers here, and we're trying to find that. Well, like I said before, what are we trying to find? We're trying to always, in our formula, find side A. So that's angle A. I'm going to label it so it matches up with the formula. Always trying to calculate side A, so there's my angle A. What does that leave me with? That leaves me with angle B and angle C, which leaves me with side B and C. And it doesn't really matter what B and C are in our formula. They're interchangeable. We could switch them around. But side A has to be across from angle A, which is what we know. So now we can plug in. A squared equals B squared, which is 3.65 squared, plus 5.18 squared. Subtract 2 times 3.65 times 5.18 times cosine, and I've run out of room, so I'm just going to jot it down here, 67.5 degrees. Once everything's labeled correctly, we know what we're solving for. Now we can punch numbers into our calculator. 3.65 squared gives us a value of 13.32. 2 decimal places will work fine. Plus 5.18 squared. Sorry, just a second. 5.18 squared is 26.83 minus 2 times 3.65 times 5.18 times cosine of 67.5, and we get subtract 14.47. So once I can plug in, break it into steps, and now I can get my value. So that 13.32 plus the 26.83, and then I subtract the 14.4, and I get for an answer there 25.68. But that's not our answer because that's what A squared is. We always finish by square rooting. And A works out to be 5.1 kilometer long tunnel. So, cosine law. It's all about a formula and understanding it. Just make sure that your formula matches up your diagrams, your A's, B's, and C's. The booklet. Not a lot of questions, but make sure you take your time. Check the answers in the answer booklet that's provided on the Google Classroom site. Make sure you're on the right track, and please ask questions if you're not sure. Have a great day, folks.